Alright, so like I said, this is our triangle. So, it's pretty cool, isn't it? It's called an oblique triangle. And today we're going to analyze this. We're going to get the hypotenuse, we're going to get the angles in this one. Ooh, pretty cool, isn't it? I like this. I like this triangle. Really good. Alright, now let's draw it on the board and see what we get. Alright, let's see. So, start putting this still. Alright. If you guys can see the screen, then I'm glad you do. If not, well, I'm sorry. The setup is kind of like, I know, pretty terrible. Okay. Very good. Okay, now we have our triangle. We're gonna name him Jimmy, because why not? Okay. Now according to our triangle, it reads here. That this side is 19 degrees. I meant 19 centimeters. My bad. I'm sorry. So this is 19 centimeters. This is 11 centimeters. Alright, so this is our A, this is our B, alright? But in our triangle, unfortunately, this does not have a measure. We don't know what this is. What's the measure of this hypotenuse? We don't know what it is, alright? So again, this is 11 centimeters. This is 19 centimeters. Now how do we get the length of the hypotenuse with only A and B is given? I know everyone knows this. This is the most iconic formula. I'll give you guys 5 seconds to think about it. You got the answer? Alright. Well, good. Very good. Very good. Very good. Great work. It's the Pythagorean theorem. So, in order to get C, we will have to take the square root of the sum of A squared plus B squared. Or, originally, A squared plus B squared is equals to C squared. Taking the square root of C squared, that's C. Our objective is to get C. So substituting the values into the formula, we will get 11 squared plus 19 squared. It's actually that simple. Now to get the square root of the sum of 11 squared plus 19 squared, square root, that will be square roots of 482. Right. Now as you can see in the board, it's probably inverted or something. I don't know. It's kind of bad right now. So 11 squared plus 19 squared, 482. Take the square root of that, get the answer. Now I have here a scientific calculator. We can approximate that, which is 21.95. 21.95. 21 maybe. Okay. So 11 squared plus 19 squared, take the square root of that, the sum. We get the square root of 482. So that's our value for C. Alright? Now we know that the measure for this side is 400, square root of 482, or 21.95 centimeters. Alright, now we know. That's our hypotenuse, alright? Now let's say we want to find the angle next. Alright, we know we don't have the angle. Okay, we have all the sides, which is 21.95 centimeters. We got 19 centimeters. We got 11 centimeters. Okay. All right. Now, as for this one, in order to get the angle for both of these, so let's say we have, this is our side C, this is our side B, side A. And now let's say our angle will be, this is wait, okay, taking for reference, let's say this is C. This is our C. This is our angle A. Angle C, angle A, angle B. I'm trying, guys. I'm not a teacher. I'm also studying this too. So basically, we're together studying this triangle over here. So don't expect me to be this good, alright? I'm not that good. I'm just trying to recall what I learned in trigonometry. But at least we have a review on this one, on trigonometry, so we don't forget, because we're still going to use trigonometry in physics and stuff, so it should be important that we still we have a consistent learning on this. So let's continue. Alright, we have the sides, but we don't know the angle. What law are we going to use? So in order to get the angle of all of these with only the given sides, so we will use the law of cosines. So what's the law of cosines? So that will be c squared is equals to a squared plus b squared minus 2ab multiplied by the cosine of c, angle C. Alright, we know that, right? Same application for others. So b squared, that'll be a squared plus c squared minus 2ac cosine b. And then same also as well as in a squared, so that will be b squared plus c squared minus 2bc multiplied by the cosine of angle A. Now, in this situation, we don't know this. These are the following that is missing. This. Alright. We don't know what's the angle ABC. We don't know that, right? Okay. So, derived from this law, we have a formula to get the following angles. So, that will be b squared plus c squared minus a squared over 2bc. This is for cosine C. Cosine C. So the formula for that is inverse cosine C. Inverse cosine this value. So let's just quickly rewrite that. Okay, if you can see this, my work. Okay, there we go. Okay, I think you guys can see it. Okay, so inverse cosine to get the angle. There we go. Inverse cosine of b squared plus c squared minus a squared over 2bc. Alright, now let's substitute values of the formula. Our formula. So for our cosine C, now to get our cosine, okay. Oh, it seems I have mistaken. This is for angle A. This is for angle A. Sorry. Okay, so this is for angle A. This formula is for angle A. We just derived it from the law of cosines for specifically for side A squared. Okay, so inverse cosine. Okay, so our angle A will be inverse cosine of our B is 19, so 19 squared plus square root of 482 squared, so that's 482, but we're going to write it anyways as it is, minus 11 squared. All right, and then 2 19 and square root of 482. All right, so now that's our formula, right? Now let's use a calculator for this one. Let's try. Let's use a calculator for this one. 19 squared plus square root of 482 squared minus 11 squared, and then 2 times 19 square root of 482. Surprise, surprise, that's approximately 30 degrees. Approximately 30 degrees. So now that we have our angle A, therefore, this is approximately 30 degrees. But in the calculator, there's actually more than that. There's still like a lot of decimals in there. There's still a lot of decimals in there. If you get, I hope you guys can still see the screen, or, you know, since you guys may not understand what I'm explaining right now. So, okay, so now we have 30 degrees. We have the formula over here. All right, we're done for angle A. That's finished. He's finished. He's cooked. He got cooked. All right. Now, I want to go for angle C. Now let's go for angle C this time. This time, angle C. Because last time I said angle C, but no, that formula was for angle A. So, still the same thing, but instead we're going to change it a bit. So, to get the angle C, we will get A squared plus B squared minus C squared over 2AB. Alright, so substituting those values to the formula. So 11 squared plus 19 squared minus square roots of 482 squared over 2 multiplied by 11 and 19. There we go. Alright, and then after that, we take the inverse cosine. So let me simply write that there, so you guys can take notes if you guys want. I'm not a good teacher, by the way. So inverse cosine. Get the angle C. There you go. And then let's do it. So inverse cosine of 11 squared plus 19 squared. By the way, you guys can correct me if I made like a mistake. So, alright, here we go. So square root of 482 squared, 2 times 11 times 19. Alright, so this is, it's in our calculator. Now let's press, what's the answer? 90 degrees. I am surprised. Surprising. Very surprising. I am very surprised. 90 degrees. It's literally 90 degrees. Like, look at that. Wow. 90 degrees. Okay, so it is 90 degrees. So, let's put that here. 90 degrees, okay. Very... is it really 90 degrees, or this is the one that's 90 degrees? I think this is the one that's 90 degrees. Don't you guys think? I mean, just visualize it. This is one's 90 degrees. Jeez. Okay. Anyways, let's continue. This, for our last one, we will get the angle B. Angle B. All right. But okay, I'm still doubting this one, by the way. You guys can correct it in the comments. I know you guys are better than me, so I believe in your skills. That's why you guys are very successful in school. Alright, have you guys been successful in school lately? How's your grades in math? How's your grades in math, guys? Been good? Maybe not, maybe yes. If it's yes, congratulations, you deserve it. You deserve that because you went on a hard work, you were working hard to get your grades up in math, or you just cheated using ChatGPT. Like me, sometimes. Or frequently. Okay, now let us move on to angle B. Angle B. So that will be inverse cosine of okay, so since we're looking for B, that will be a squared plus c squared minus b squared over 2ac. Alright, now, okay, we get that. So, now we get that. Boom! So, our angle B will be the inverse cosine of 11 squared plus square roots of 482 squared minus 19 squared over 11 times square root of 482. Alright, so applying the formula, let us do that once again. So that will be 11 squared plus square root of 482 squared minus 19 squared. So 2 times 11 and square root of 482. Okay, now clicking that, we get 59.93 degrees. 59.93 degrees. Or 59.9. Technically, if we just round up just from the first decimal number, which is 9, so that's technically 60 degrees. It's technically 60 degrees. We round it up. Okay. 60 degrees. Alright. Wow. I mean, look at this. 369. 369. It's crazy. That oblique triangle is crazy. Alright. Now I want to show you guys some cool tricks in trigonometry. Ratios. Trigonometric ratios. Alright, SOHCAHTOA. You guys still remember that? Okay. So sine theta is equals to what? Opposite over adjacent. Opposite hypotenuse. Fuck. Did I just said adjacent? Yeah, sorry guys. I meant sine theta is opposite over hypotenuse. The reason why I accidentally said adjacent is because the trigonometric ratio that I'm obsessed the most is tangent. I love tangent. That's why. That's why I accidentally said that. But correction is opposite over hypotenuse. I'm making so many mistakes now. Okay. What's our cosine? Cosine theta. Adjacent over hypotenuse. You said I'm going to say adjacent over adjacent, huh? adjacent over hypotenuse. Imagine someone watches my video just to cheat on their exam, and then they hear when I said opposite over adjacent, and they immediately answered it on the quiz. I think I will take the blame for that. Guys, watch the video, watch educational videos clearly. Don't skip any parts, because sometimes YouTubers like me, when explaining these things, we do make mistakes, and we immediately say the corrections. So don't you ever skip a part in an educational video such as this, math, especially this one. Just my advice. Just take my you can also not take my word for it, but I'm just saying that don't skip parts. Definitely do not skip parts. Anyways, from my first mistake, that's actually tangent. So basically that's opposite over adjacent. My handwriting sucks ass, I know. Alright, opposite over adjacent. Now we get that. Okay, we got that, right? Now I will show you that all of this will produce the same angle when we inverse it by itself. Like inverse sine, inverse cosine, inverse tangent. This will produce the same angle. If we just... Alright? Okay. Now, watch this. Opposite. What's our opposite? A. That's basically A. So 11. What's our hypotenuse? Square roots of 482. Now take the inverse sine of this. Right? Alright? Alright, let's just erase that and then rewrite it as inverse sine of 11 over square root of 482. So inverse sine of 11 over square root of 482. Alright. Inverse sine. Now, let's try that. 11 over square root of 42. $30. 30 degrees. Here's the proof. Proof, 30 degrees, that's 30. 30. Alright, next one. Cosine. Alright. Inverse cosine. What's our adjacent? 19. 19 over square root of 482. Now let's check again. $30 degrees. Also 30 degrees. Inverse tangent. Inverse tangent. Alright. Inverse tangent. 11 over 19. What will be the answer? Also 30 degrees. Now, as you can see, all of these produce equal angles. All of this will produce the same angles if we know the hypothesis, opposite, fuck. Why did I say hypothesis? I'm not in research. I'm not in research. Okay. Anyways, if we know our opposite side and if we know our hypotenuse, we can easily get the angle between them. Now we can easily get the angle if we know the opposite and hypotenuse using the inverse sine. Same goes for cosine, same goes for tangent. If we don't know the hypotenuse, but we have the opposite and adjacent, simple. We can we can just get the angle by using the inverse tangent. And then divide 11 over 19, boom, we get the angle. Same goes for cosine and sine. If we don't know the adjacent but we know the opposite and hypotenuse, there's no need to worry about getting those angles. All right. Now, so I guess it leads to this angle over here. This is the angle that the sine is calculating. Okay. So moving on. Now, let's have a little bit of situation. Let's have another case scenario where we don't know this. Okay? We don't know the hypotenuse. We don't know the hypotenuse. Okay. Watch this. Now sine theta. Sine theta is equals to 11 over square root of 482. Yes? 11 over square root of 482. Yes? Now look at this. It's gone. It's gone. I erased it. Now I don't know what this is. But for sure, I know that it's 30 degrees. I know that it's 30 degrees. Or in a calculator approximate, yes, that's 30 degrees. Okay, so I know what that is now, 30 degrees. But I don't know what the hypotenuse is. So what do? Okay, so we just replace the role of sine 30 and hypotenuse. So, let's say our hypotenuse is written as c, because that's how we usually write hypotenuse as. Okay, so 11 over sine 30. Actually pretty simple. 11 over sine 30. That's how we get the missing value of c. 11 over sine 30. Okay, so now we know that. Now let's check if it produces the same answer. So now let me just quickly do this. Okay, there we go. Got the angle. Okay. Now 11 over sine, over here, sine answer. Okay. We may have oh shit. We may have a bit of mistake here. What the fuck did it become 22 degrees? Not gonna lie, chat, I think we're kind of close. I mean, technically that's kind of close. Wait, I'm correct. Fuck, I'm tripping. Oh my gosh, okay, 21.95. Okay. 21.95, same thing. 20... Where did I put 9 first? 21.95 C. Alright. And we got that. It's over there. It's over there already. Right? I mean, technically 11 divided by sine 30, that's 22. But since I've used the approximate version, it's 21.95. So that's the same thing. It's correct. So it does lead back to its hypotenuse. Now what if this? Sine theta. Alright? Okay. So 11 over square root of 482. Alright? 11 disappears for no damn reason because his plot armor has expired. Right? Now 11 disappears. Now what do? We multiply this in here. This is the since this is the denominator, okay, we multiply this. Now don't take my word for it, but I think it's because this is directly proportional. The hypotenuse is directly proportional to the sine of this angle. So since it's directly proportional, therefore our A is equals to square root of 482 times the sine of the approximate 30 degrees. Okay. Alright, square root of 482 times sine the approximate 30 degrees. So we know that. Okay. Let's just quickly go back. Okay, storing my answer. Okay, so square root 482 multiplied by sine answer 11 goes all the way back to 11. Okay, goes all the way back to 11. Goes all the way back to 11. The same thing happens to cosine and tangent. Those same principles apply. If the numerator is missing, you multiply the denominator by the angle. If the denominator is missing, you divide the numerator by the angle. The cosine, sine, tangent of the angle. That's pretty much it. That's our principle. That's a known concept in trigonometry, and this is simply our review. Okay. So what else are we we can talk about here? What can we talk about here? Is there anything else to talk about here? Okay. Now, let's say erase that. Erase that. Erase the hypotenuse. Screw that. Be gone. We leave this 11 centimeters. Alright. Now this is a new situation. We have the angles and then some one side, but there are missing two sides. We don't know the sides anymore. Normally this is 19, right? This is square root of 482. Alright, this is our last part of the review. Okay. So what law are we going to use now? Now that there's angles given and one side is given. Alright. I mean, it can be like I can also remove this, but that could probably be in a part 2 of the trigonometry review, because I'm probably making a series of trigonometry reviews. So yeah. So we're going to use law of sines. Law of sines. Now we're going to use the law of sines. So what is the law of sines? So let me read it out for you. In any triangle ABC with sides A, B, and C, the sides are proportional to the sides of their opposite angles. Now, in mathematical forms, that is A over sine A is equals to B over sine B, angle B, equals to C over sine C. That is technically the summary of the law of sines. Now, how do we get the sides? Now, how do we get the sides for the sides? Okay, so we know these are the angles, the given angles. Now, C and B is missing, so in order to solve for B, we're going to use this formula. B is equals to A sine B, angle B, over sine angle A. This will get us the side B over there. We just derived that from here since B is missing. So we use this two. These two. We combine these two. Alright? So there we go. So substituting the values of the formula. So our side is 11. We got 11. And then we got the angle B, which is 60. So sine 60 degrees. Sine A, which is this, sin 30 degrees. That should give us the angle. Now here's a problem because all of these are approximated. Except for this, 90 degrees is not approximated. This is a perfect 90 degrees. These two, we just approximated this. So, yeah. We just approximated that. So in order to confirm back, so let's just bring back 19 there real quick. Let's just confirm for our angle B. Let's just confirm for our angle B. So that will be inverse cosine. Inverse cosine for angle B is a squared plus c squared minus b squared over 2ac. Okay. Now I just want to... So we're going to list down the different angle, the actual value for angle B and A, because we have to be very accurate here. We have to be very accurate in here. Alright? We have to be very accurate in here. So we got a squared is c squared, which is square root of 482. I'm not going to write it back down because since we're now going to solve for the missing sides, see if they have connection, if we can bring them back using the law of sines. Okay. So cosine 11 squared plus square root of 482 squared minus 19 squared. That will be 2 multiplied by 11 and square root of 482. Okay, so 59. So our angle is 59.93 141 718. Right. We got that. We got that. Okay, now as for 30 degrees, I already know this. So that's 30.06858. I stored the answers in the scientific calculator, that's why. 282. So I stored the calculations. Okay, now these are the actual approximates without rounding it up. Okay? So now we have that. So we don't need to rewrite this, or we can rewrite this if you guys might get confused. So 11 sine 59.93 141 718. Okay. And this will be sine, and then sine 30.06858.282. Pretty big numbers, huh? Pretty big numbers, I'm telling you. Okay, so 11 sine. Okay, 718 is going to be a very long calculation. Sine 30.06858.282. Let's see if we blow the turn. Abracadabra, we got 19. Very good. We got 19 back. We got 19 back. Congratulations. We got 19 back. All right, now let's go for C. Now let's go for C. Now let's go for C. Now to get the value for the side C, we just simply write it as A sine angle C over sine A. Alright. So basically that's our formula. Now let's substitute value. So 11 sine 90 degrees. There's no need for approximation for 90. It's a perfect value. It's literally just 90 degrees. So sine 30.06858.282. Now before we get the value of this, I just want everyone to be familiar with the full approximation of square root of 482, because that's our hypotenuse, isn't it? Okay. So that'll be 21.9544984. That's our full approximate for square root of 482. Now, let's solve for this. Let's see if the same thing. So 11 sine 90 degrees sine 30.06858.282. Alright. Congratulations, we also got it back. The square root of 482. Alright, so our square root of 482 has returned. Very nice, isn't it? We got it all back. So there is a connection between law of cosines and sines. Both tools are helpful in case you're looking for the missing angle, for the missing sines. These two are very, very useful tools. And I think that we should remember this because it's going to be very important. These are just some review of mathematical concepts, mathematical, practice. We just practice some calculations. We just analyze this, all of this for this triangle, by the way. This triangle alone. So there it is. That's our review for law of sines, law of cosines, and then the Pythagorean theorem, all of this, and as well as trigonometric ratios. So now we have an idea of some tools and tricks we can use to make our trigonometry problems much easier to solve. So, I think that concludes our class. Shit, not even a fucking teacher. I didn't even explain why that thing happens. I just know that it's that. Okay, so I hope you guys enjoyed this video. I hope we had a good talk to each other, even though this is just a pre-recorded thing. So that concludes our triangle over here, our precious triangle over here. Very beautiful, isn't it? I know it does. I know it does. So there we have it. Trigonometry, the beauty of triangles. I want to lick this thing, you know. I want to kiss this thing so hard. But anyways, thank you all for watching to my class. Thank you all for standing by to my pointless class, where you understood nothing about why that happened, why this shit happens. But at least you guys know the formulas now, the tricks to solve this. So, see y'all later. Bye-bye.